Hello, just I want to introduce a cartoon of the Fermi golden rule. Fermi golden rule. Okay, just I will introduce something very easy. Okay, we know that in 1934 Fermi assumed that in beta minus process the electron and antineutrino were created during the process of beta decay. For example, when okay, this is kind of a picture of the process when the neutrino, for example, in neutron decay, if we start from the top and we go up, we have one neutron. This neutron in this point that I am drawing here will convert or will transform to a proton here and will emit an electron here and antineutrino. Okay, so in this picture we have a transition. Okay, we have a transition between neutron and proton. Neutron will transform to a proton, will be emit an electron and will emit an antineutrino of electron. Okay, so in this process the transition rate can be determined from the transition rate can be determined from this equation. Usually we use the Greek letter lambda. The transition rate is one constant here, that is 2 times p over each bar, which multiply the transition, or yes, the amplitude of probability of initial nucleus and final between one interaction. Here we have the interaction, and here we have one final nucleus, one initial nucleus. Here we have initial nucleus, okay, and this is squared, and this matrix, or this probability of this matrix element, will multiply by this quantity, the n. Okay, this quantity okay, we use a quantization of a volume box normalized to a volume for electron antineutrino wave functions. Okay, this is the density of the states. Okay, This is the basic Fermi golden rule. Here we have the interaction. This is the initial nucleus, and this is the final nucleus. Okay, and that's all for the moment.